Hello. So in this module we try to understand how the PN junction works. So here you see this is a P type of semiconductor which is called as P doped. This region is called as N type of semiconductor. So P type of semiconductors is filled with plenty of holes and N type of semiconductor is available with plenty of electrons. So the majority charge carriers in P type of semiconductors are holes and the majority charge carriers in N type of semiconductors are electrons. So what happens when P type of semiconductor material is joined to the N type of semiconductor material as shown by this line right over here. So the electrons, which are the majority charge carriers, and the holes, which are the positive charge carriers and the majority charge carriers in the P type, they try, because of the electrostatic force, they try to diffuse from one region to another region. From one region to another region. It means holes try to migrate to the N type region and electrons try to migrate to the P type of region. So this process is called as diffusion process. To certain extent, the electrons travel to the P type of regions and fill some of the holes as shown over here in the blue region. So holes are filled with the electrons which travel from N type of region. Similarly, some electrons gets filled by the holes in this region when the holes travels from P type material towards the N type of material. So this region is called as space charge region or depletion region. So there is a built-in voltage because this red symbols, they are called as positive ions, and these blue symbols, they are called as negative ions, and this region is called as space charge region, and this forms a built-in potential or built-in voltage across the PN junction. It is also called as delta V. Now look at the charge carrier concentration in the log scales. So as shown in the red, there are majority carriers in the P type semiconductor which are holes. There are plenty of charge carriers and their profile carrier concentration decreases. In the depletion region it goes down, and in the N type of semiconductor material it is obvious that the holes will be minority carriers. Similarly, as shown in the blue line, there are plenty of electrons in the N type of semiconductor and their concentration in the depletion region decreases as shown over here, and in the P type of semiconductor electron concentration is minimum, that is, they are the minority carriers. Now let's define some electrical quantities such as charge with respect to x-axis, how we see their profile. The electric charge, as you can see here, in the depletion region, in the blue zone where the negative ions are shown, you see that the charge is maximum right over here, and at the junction it is 0, and again in the depletion region where positive ions are present as indicated by the red dots, the charge is again maximum. Similarly, electric field starts from the P type of material, and in the depletion region at the junction it is the maximum, negative maximum, but in the depletion region in the negative ions in the blue it is increasing negatively, and then towards in the positive, in the red region where positive ions are there, it is increasing towards the zero. As I said, because of this diffusion process forms the depletion region, and you have positive ions and the negative ions. This is the region where we also called as absence of charge carriers. This region does not hold electrons or holes, rather it holds positive ions as shown in the red and the negative ions as shown in the blue. So, and this process forms the built-in voltage. So the voltage profile is shown over here. As we can see, it is showing that in the depletion region, that is this region, we see that the voltage is there, and this much voltage is called as delta V, that is the built-in voltage. So now with this semiconductor, when two semiconductor materials are joined to each other, it is called as PN junction. And if we want the electricity to flow in this device or in this junction, we apply an external voltage to this PN junction, and by means of externally applied electric field, we have to overcome the depletion region voltage, that is the barrier voltage or built-in voltage, so that the electrons will flow from one region to another region. In other words, the holes, we also can say, will flow from P type to the N type of material, and the circuit will be completed. So it would be shown something like this. So you have this P type material, you have N type material, you apply an electric voltage across this material, and because of that you have positive terminal and negative, the current will flow, and the electric field will push the holes, and it will cross the barrier and go to the N type of material. In other words, we say the electrons will be pushed from N type of material, and they will travel to the P type material after the electric field that we apply externally overcomes the internal barrier voltage of the PN junction. So this is how we understand the physics of the PN junction and how the processes are happening. What we understood, what is meant by depletion region, we understood how the built-in voltage is produced and how we can make the conduction possible in this device.